All right, section 6.1, in my opinion, is a pretty easy section. We're just getting introduced to the idea of polygons and classifying them. We will also find angle measures of quadrilaterals. This whole chapter is mostly about quadrilaterals, so it can be a bit of a challenging chapter just because there are a lot of things to remember. We'll just have to make sure we're studying as we go, taking good notes. All right, first our definitions. Polygon is a plane figure. Plane figure meaning like two-dimensional, flat. Plane figure that is formed by three or more segments called sides. Each side intersects exactly two other sides at each endpoint called a vertex. Okay, so we've got a few examples of what polygons can look like. So if you wanted to, you could label that this is an example of a side. This corner is an example of a vertex. And that's true for any of these. So notice each side has two vertices on it. Touches two other sides. There are some other things to notice that we'll talk about more when we get to some examples about what is not a polygon. So things that we do not see would be curves. You know, like try to make a separate box down here for things that are not polygon features. Would be things like a curve. Okay, so if your figure had some sort of round part to it, like a circle is not a polygon. If it's open, meaning you have one side that doesn't meet the other side, there's a way you can get into the shape, that's not a polygon. I guess I could give you a picture for a curve also. If the sides intersect each other or overlap, or intersecting sides, meaning something like that, where they crisscross each other, that's not a polygon. Okay, so a polygon has to be closed, meaning you can't get inside of it, but not crisscrossing each other. No round edges anywhere. Questions, concerns about what is or is not a polygon? We'll see some more examples later on. Okay. A diagonal is a segment that joins two non-consecutive vertices of a polygon. So this figure has many diagonals in it. So a segment connecting two non-consecutive vertices. That means they are not right next to each other. A side connects consecutive vertices. Non-consecutive means they're not next to each other. So if I wanted to draw a diagonal from the top vertex, I could draw it not to this next one because it's consecutive, but down here this is a non-consecutive one. Over here would be a non-consecutive vertice. Those are the only two diagonals I could draw from that top vertex. The other two vertices are right next to it. But you could start at a different vertex and draw its diagonals. And you could do that the whole way around the figure to get all of the diagonals that belong inside that vertex. Questions about what a diagonal is? Okay. Classifying polygons by the number of sides they have. This is one of those first things that you're going to have to memorize, basically. However, many of these you probably already know. What do we call a three-sided polygon? A triangle. You already know that one. Not a big deal. The next one gets a little tricky for some people. Anybody know what we call a four-sided polygon? A what? A quadrilateral is the correct response. You cannot call it a square or a rectangle unless you know certain things about it. So if all that you know is that it has four sides, you can only call it a quadrilateral. As we go through this chapter, you will learn about many different types of quadrilaterals, including squares, rectangles, rhombuses. But if you don't know any of the defining features of it, you don't know if it's a square or a rectangle or just some generic quadrilateral. 5 sides. Pentagon. 6 sides is a hexagon. Anybody know 7 sides? That would make more sense. It's a heptagon with another H. Heptagon. 8 sides is an octagon. 9 sides is a nonagon. 10 sides is a decagon. And if it has more than 10 sides to it, like it has 13 sides, we would call it a 13gon. So if n represents some number, we would call it an n-gon. So it could be a 13gon, a 52gon. It sounds silly and it looks silly, but that's how it works. So just as an example, if it had 52 sides, it would literally be called a 52gon. For 12 sides, there technically is a name if you want to add it into your notes. For 12 sides, it's called a dodecagon. I'll write it on the side there. 12 sides is called a dodecagon. There isn't really one for 11 sides that is universally agreed upon. Questions, concerns, need more time filling out this table? Okay, we'll move on. The sum of the measures of the interior angles of a quadrilateral is 360 degrees. That is the quadrilateral interior angles theorem. Another thing that we need to just have memorized. But this really isn't so bad. We did talk about the sum of the interior angles for a triangle several times. Inside of a triangle, what do all of the angles add up to? 180. So for a quadrilateral, they just have to add up to 360 instead. Which should make sense because any quadrilateral, if you think about a quadrilateral of any kind, you could always split it into two triangles, right? So if this has to add up to 180 and this has to add up to 180 and we put them together, then the whole thing adds up to 360. Questions, concerns, need more time? Okay. Moving on. Is the figure a polygon? Explain your reasoning. I'll really only ask you to explain if it's not. If it is, you would really just be stating the definition of a polygon every time. So if it is not a polygon, you need to tell me why. So on problem A, is it a polygon, Jasmine?
No, because it has curves.
Very good. No, it has curves. Done. If there are some sort of curves involved, then it doesn't work. Letter B, do we think that's a polygon? Yes, it is. It doesn't break any of the rules. So it's got all sides that are just segments connecting at vertices. That one is definitely a polygon. What type of polygon is letter B? A hexagon. Very good. We might as well practice naming them while we're here. On letter A, we wouldn't give it a polygon name because we said it was not a polygon. So on quizzes, tests, homework, things like that, a lot of them will have you name them if they are polygons. So if they're not, you wouldn't give it a name. Letter C, I think you have to draw that one in. Is that one a polygon? No, why not? Okay, it intersects or overlaps, crisscrosses. Now, if we were to kind of cut it right there in the middle, this would be two separate triangles, but when it's put all together like that, it is not considered a polygon anymore. What about letter D? Yes. That one does fit the description for a polygon. What type of polygon is it?
Pentagon.
A pentagon. What about letter E? Yes, this is considered a polygon. Does anybody know what kind of polygon it is? It's a decagon. Ooh. Ooh. Okay, so the reason some people don't like to think of letter E as a polygon is because the sides kind of cave inward, which that is a feature we will talk about possibly tomorrow even. But it still is a polygon, so it's not curved, it doesn't overlap, there's not an opening left. So even though it might look a little bit different than the ones where all of the edges or corners poke outward, these ones kind of poke inward, it's still a polygon. Questions, concerns? Okay. Last two, find the measure of angle V, which would be the ones labeled with variables. On to A. We're trying to find the value of that angle that's missing. So we have to use that theorem that we just talked about on the front side of our notes, that all the interior angles of a quadrilateral add up to 360. So you could just take 360 and then start subtracting off the angles that you know all the way around, or you could add them all up and then subtract one number from 360. Either way you do it, what do you get? 99? That sounds about right. So the measure of angle V is 99 degrees. Or you could just put on this one X is 99. I would be okay with that. Questions about how we got 99 degrees? Okay, same kind of thing on letter B. We could add these up first this time. Plus 67, plus 131. 14, carry that 0. So those ones that we already have should add up to 304. And then we could take 360 minus that 304. And this time what do we get? 56. Now, if you didn't want to add those up and subtract one big number, you could do it like we did on letter A, where you just subtract each one off one at a time. But this time, the measure of angle V is 56 degrees. Now, don't start putting this up just yet, because I do want to do one more example that's not printed on there just yet. But we've got space to add it. Do we have questions, concerns, need more time with number 2? A or B? Okay. Then I want to add a number 3 where we will find the value of X. So there's another common problem that you could see. Now, I am going to make my quadrilateral look like a rectangle. That doesn't mean that it is. Okay, because I'm not going to mark the 90-degree angles or anything like that. So instead, I'm going to fill in all of these angles with variable expressions. So I'll make this one 3x degrees. This one up here will make 2x minus 5 degrees. We'll make this one, let's make it 5x plus, oh, I'm running out of space there. 5x plus 20 degrees. And we'll make this one 3x plus 15 degrees. I'm going to change that to a 2x instead of a 3x on that last one. 2x plus 15. Sorry. Trying to see if I can make this come out right. I'm not sure if it will. Or come out nicely, I should say. Now, if I'm trying to find the value of x, some of you have probably already figured out what my game plan was here. What do we need to do with all of these? Add them up and set them equal to 360. So sometimes you might not know any of the angles when you start off. And you will have to come up with an equation where you add up all of this stuff together. This is not a lot different than when we did this with triangles. We just have another angle to throw in there. So I just added all of these together. When I do that, I'm going to end up with what expression on the left side? 12x plus 30 equals 360. Okay, so we just had to add up all the x's together and then combine all of the constants together. Now to solve this, we would subtract 30, and we would have 12x equals 330. Next we would divide. I don't think it's going to come out super nice, but what do we get when we take 330 divided by 12? Okay, 27.5. Does that deserve a degree symbol? No, because it's just x. It's not an angle measure. So the 27.5 does not deserve a degree symbol on it. However, if I were to then ask you to find the measure of, let's say, angle D, if I were to label these vertices, and I want to know the measure of angle D, what am I going to have to do with this? Plug it in. So the measure of angle D would be 2 times the 27.5 plus 15. So that is 55 plus 15. So we get 70 degrees for the measure of angle D. Okay, so this clearly is not drawn to scale if this is only a 70 degree angle. So I would never go based off of what it looks like. Go based off of any markings that you're given or measures you can find. Questions, concerns about any of this? Need more time absorbing it? Okay.